Let us look at this question. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. What is the vessel? It is the combination of two figures, a hemisphere and a cylinder mounted on each other. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. We need to find the inner surface area of the vessel. Also, we need to take pi as 22/7. Let us try to draw that figure. If we talk about this vessel, which is a combination of a hemisphere and a cylinder, you may see over here, I have already drawn the figure. If we look at it, what is given? This is a hemisphere of 14 centimeter diameter and there is a cylinder mounted over it. The total height of the vessel is 13 centimeter. Okay. Oh, this is the 13 centimeter and the the diameter of this vessel is 14 centimeter. If diameter is 14 centimeter, we can say that its radius is going to be 7 centimeter. That means this portion is also 7 centimeter. By this, we can find out the height of the cylinder as it is looking over here. Let us write it as well. If we write that what is given to us, we will first start with the diameter of hemisphere. What is the diameter of hemisphere? It is given as 14 centimeter. So if the diameter of hemisphere is 14, then we can conclude that radius of hemisphere, which also happens to be the radius of the cylinder, is 7 centimeter. Okay. Now, the total height of vessel is equal to 13 centimeter. This implies that height of cylinder is going to be the difference of this radius 7 and the total height. So 13 centimeter minus 7 centimeter, that gives us 6 centimeter. So we just have found out the height of the cylinder H and also the radius of cylinder and radius of hemisphere R as 7 centimeter. Okay. Now, since we need to find out the inner surface area of the vessel, what will be the inner surface area? The inner surface area will be this total portion, isn't it? So, to find this inner surface area, I need to find the CSA of this cylinder and the CSA of this hemisphere, and we need to find the sum of these two areas. When we get the sum of these two areas, that will be equal to the inner surface area of this vessel. So, let us find it out. Now, as we are in the need of finding the the inner surface area, so we will write it as inner surface area of vessel will be equal to CSA of cylinder plus CSA of hemisphere. So if we solve it, we are going to get the inner surface area. I am writing at inner SA as, what is the CSA of a cylinder? We know the formula for it is 2 pi r h. And what is the CSA of a hemisphere? It is 2 pi r square. If I take out some common terms, I am left with 2 pi r outside and h plus r inside the bracket. Let us now substitute the values. 2 multiplied with pi, that is 22 by 7, multiplied with radius r, that happens to be 7, and then we need to write h as 6 and r as 7 again. This 7 cancels this 7. 2 times 22 is 44 and 6 plus 7 is 13. This all is going to be in centimeter square, and if we want to find out the product of 44 and 13, it's quite easy. We can do it on the sides. 44 times 13 will be how much? 3 times 4 is 12. Carried forward 1, 3 times 4, 12. So it is 13, 4, 4. So 275. So it is going to be 572 centimeters square. This is our required answer. So look, what have we done? We have what have we done? We just found out we are in the know of the diameter of the hemisphere as 14 centimeter. We found out the radius. We got the height of the vessel. So we found the height of the cylinder, and then we used the CSA of cylinder and CSA of hemisphere to get the total inner surface area. So the inner surface area which we got is 572 centimeters square. So this is the required solution for this problem. I hope it is clear.